Let's talk about what might just be the single most famous, most baffling, and most important experiment in all of science, the double-slit experiment. You've probably heard of it. It's been called the very heart of quantum mechanics, a puzzle that has left physicists scratching their heads for more than a century. But what if it holds a surprising secret?
I mean, listen to this. The legendary physicist Richard Feynman himself said, "This one experiment contains the only mystery." When a mind like Feynman's points to something and says, "That's it, that's the central puzzle of reality," you know we're dealing with something incredibly deep. He was convinced that if you could just wrap your head around this, you'd understand the bizarre core of the quantum world.
But what if we've been looking at it backwards this whole time? What if all that quantum magic is actually rooted in something much more fundamental, something almost intuitive? What if the answer isn't magic, but just geometry?
To really get this, we need to rewind the clock, way back to 1801. A British scientist, Thomas Young, sets up a pretty simple experiment. He wants to settle a huge debate of his time. Is light made of particles, like Isaac Newton thought, or is it a wave? His simple setup was about to change physics forever.
Okay, so on the left, you see what everyone expected. If light is made of tiny particles, like little paintballs shot through two slits, you'd get two simple stripes on the screen behind it. Makes sense, right? But on the right, that's what Young actually saw, a weird pattern of many bright and dark bands. That's an interference pattern, exactly what you see when two sets of water waves meet and interfere with each other. So, light's a wave. Case closed? Well, not so fast.
Because in the 20th century, we got better toys, and we ran the experiment again with a crazy twist. We fired single particles, individual electrons, one at a time. And somehow, impossibly, after thousands of these single shots, that same wave interference pattern built up, dot by dot. How? How can a single particle possibly interfere with itself? It's as if each electron went through both slits at the exact same time.
To get a handle on this, let's just forget quantum physics for a second and think about a simple choice. Because the key to this whole puzzle isn't really the particle. It's the number of slits. It's the choice itself.
Imagine a traveler comes to a fork in the road. Now, if there's no way to know which path they took, no witnesses, no footprints, nothing, their journey is ambiguous. In a very real sense, their state is left path plus right path. Both possibilities are still in play. But the moment we find a single footprint, that ambiguity collapses. Now we know it was left path or right path. The possibility becomes a fact.
And here's the crucial insight. 2 is the absolute minimum you need to create a choice. It's the atomic unit of ambiguity. 1 slit, no choice, no mystery. But 2 slits, that creates a fundamental fork in the road for reality. It forces the universe to deal with 2 possible histories for that particle that are, for a moment, completely identical and indistinguishable.
So, the obvious next question is, what happens if we try to peek? What if we try to get rid of that ambiguity by actually finding out which path the particle took? Well, this is where it gets even stranger.
And this just lays it out perfectly. The moment you place a detector at one of the slits to see which way the particle goes, poof, the interference pattern completely vanishes. It's gone. And you're left with those 2 simple bands we expected from the very beginning. The simple act of gathering information, of knowing, forces the particle to behave like a plain old classical object. And let's be really clear here. This has nothing to do with a conscious person watching. It's all about information. To know the path, you have to interact with the particle somehow. That interaction, no matter how gentle, leaves a record, a footprint. And once that information exists anywhere in the universe, the 2 paths are no longer indistinguishable. You can't have interference anymore, because one path has been singled out from the other.
So this all feels like some kind of quantum wizardry, but what if it isn't? A really compelling new framework suggests the answer is something much more fundamental, pure geometry. Let's walk through how this idea works.
Okay, to understand this, you have to stretch your brain a bit. Forget about our normal 3-dimensional space for a second. Instead, imagine a vast, abstract space that contains every single possible path a particle could take to get from the starting gun to the final screen. This is the real arena where the action is happening.
So this new theory proposes that everything that happens in this space is governed by one master equation. Now, don't worry about the symbols. Seriously, the core idea is incredibly simple. The probability of any given outcome is all about its geometric distance from some optimal state in this big space of possibilities. Paths that are geometrically closer to an ideal path are just more likely to happen. That's it.
And here's where it gets really mind-blowing. This new language of geometry maps directly onto the standard and frankly confusing math of quantum mechanics. The weird quantum concept of phase, in this framework, it's just distance. The mysterious Planck's constant, it acts like a kind of temperature for the system. And the famous wave function, it's just a geometric probability distribution. It's the same reality, just described in a much more fundamental language.
So, from this geometric viewpoint, interference isn't weird at all. It's the totally natural, inevitable result of just adding up all the possible paths in that configuration space. The light and dark bands we see on the screen are just the geometric echoes of all those possibilities. Some paths reinforcing each other, others canceling each other out.
All right, so this is a fascinating new way to think about a century-old physics problem. But you might be wondering, does this principle of interference actually show up anywhere outside a lab? Oh, you have no idea. It's absolutely everywhere. Those noise-canceling headphones you wear, they work by creating a sound wave that destructively interferes with the noise coming in, literally creating silence out of sound. Holograms are just frozen interference patterns. The incredible LIGO detectors that sense gravitational waves from colliding black holes, they're gigantic interferometers. And of course, the entire engine of quantum computing is built on harnessing and controlling this very interference of possibilities.
So the big takeaway here is this. What we call quantum weirdness might not be weird at all. As one physicist put it, the universe isn't performing some magic trick for us in the double-slit experiment. It's simply doing geometry on a scale we're just not used to seeing.
And that leaves us with a pretty profound final thought. This experiment really forces us to ask what reality is fundamentally made of. Is it a collection of definite, solid things like tiny billiard balls? Or is it a vast geometric landscape of possibilities, which only solidifies into one single thing when information forces a choice? Something to think about. Thanks for joining me.